Right. So from here, the numerator, I have shown you how to simplify. So this is how you do it. From that step, go to that one. Okay, but I need to move my bar here and so that I can have the square. So we have got that. Okay, that's the simplification to get the numerator. Okay, so when you write it down, allow me to reduce this a little bit. So I'm going to zoom out. Okay. So that's the working out to get the numerator, which means my next step here is to write minus, or rather I can write positive. In fact, I can write minus sine theta all squared, all over. The denominator cos 90 plus theta, I have got it here. It's equal to minus what? Sine theta. So this gives you minus sine theta times sine 180 minus theta here is equal to sine theta.
So, sir, will this be have any
Right, let me warn you, these reduction formulas, they are not provided in examination. Okay? They are not provided in examinations. You have to memorize them. Alright, then from there, we have sine squared theta all over. Now, minus sine theta times sine theta will give you minus sine squared theta. And this is equal to. Now, I'm sure you can see now that we have a sine theta in the numerator, we have a sine theta in the denominator. But there's also this minus here, which means our final answer, we are going to be left with a 1 in the numerator and a negative 1 in the denominator, and we get negative 1 as the final answer. Okay, so it's not very difficult. All right? Any question? So we are going to reduce all those angles to acute angles, that is angles between 0 and 90 degrees, using the reduction formula, those ones there. We might use the co-ratios, but we are going to use those ones too. These 12. So let's start with the first one. Right? Sine 310 degrees. Okay? 310 degrees is in which quadrant? The fourth quadrant. Right? Which angle can we subtract from 360 to get 310? 50. So we can write this as sine 360 degrees minus 50 degrees. We are going to rewrite sine 310 using an acute angle. Okay? And your knowledge of quadrants is required. Okay? In actual fact, in this grade, you need to know quadrants more than last year because of the reduction formula. Then here, this 50 degrees is like your theta in the reduction. This theta here. Okay? Which means my answer here is going to become minus sine 50 degrees. Okay? No calculator. So this will be your answer. This angle 310 is in the fourth quadrant. Which angle can we subtract from 360 like this to get 310? Which acute angle can we subtract from 360 to get 310? So 310 degrees can be written as sine 360 minus 50 degrees. Do you agree with me that 360 minus 50 is equal to 310?
Yeah.
And then we apply the reduction. No calculator, by the way. I'm not supposed to use a calculator to do this. Yes?
So why do we use 360 instead of top?
Because the angle is in the fourth quadrant. 310 is in the fourth quadrant. Okay, yes? Don't worry, we'll do one way, you need to use 180. B. Yes.
So we basically have to look at the angle
Solve the angle.
Yes.
See which quadrant it fits in.
Yes.
That not the full angle of the quadrant goes.
Yeah, but it will depend now on in which quadrant it is. If the angle is in the first quadrant or the third, we use 360 as our reference. If it's in the second and the third, we use 180 as our reference.
Oh, you're using it.
Okay, 310 is in the fourth quadrant.
Yeah.
That's why we have to subtract an angle from 360 to get 310. All right, let's move on to B. Now B, in which quadrant is 110 degrees? Second quadrant. Therefore, we are going to introduce 180 now as our reference. Which angle can we subtract from 180 to get 110?
70.
70. So this becomes tan 180 degrees minus 70 degrees. And then you go back to the reduction, it becomes negative tan. So this will be negative tan 70 degrees. You are not supposed to use a calculator. I want to remind you, no calculator. Okay? You penalize.
How are you gonna
Alright, then G. Yes.
How do you determine the size of the final answer?
No, if your question comes like this, where it says, write the following as a function in acute angles, it will say without using a calculator. So when you get here, you don't have to punch minus tan 70 in your calculator. You don't have to. You just leave it like this.
Okay, how do you determine whether it's negative tan or positive?
The reduction formula. You see the reduction there. You are going way more about the reduction. Yeah? Let me warn you. I don't want you to end up crying after the gene control test. Okay? You need to sit down and memorize this reduction. That's why I told you since Monday, okay, since Monday, when I wrote them down, I'm not going to erase them, okay, until we finish this part that you don't need to copy this down. We've got it already.
You copied
The first lesson that we did last week on Wednesday. All right, then G, so we have got tan 235 degrees. In which quadrant is 235?
Third.
In which quadrant is 235?
Third.
The third. Don't worry, I'll go over it. Generally, I don't like to do the question because of time constraints. Okay? But I will do it for your sake. Right. Tan 235 is in the what?
Third.
Third quadrant. Which angle can we subtract from 180 to get 235? Which angle can we add to 180 rather?
55.
Which angle can we add? 55. Now here we are adding now because 235 is more than 180. We are in the third quadrant, so we add the acute angle. So this becomes tan. We split this up into 180 degrees plus the acute angle.
So
Yes.
What if we
why
say
do you put it in that
I gave you a definition the first day. It's very sad that you are asking me that question because, yes, I told you, reduction formulae are a group of formulae that are used to reduce trigonometric ratios of obtuse and reflex angles to trigonometric ratios of acute angles. First lesson.
Would
Yes.
it be wrong if we said 270 minus 35?
Where?
Then.
Okay. Generally, we don't use 270.
So then minus is 1.
Yes.
We don't use 270. 270 will complicate things. So we use 360 degrees and 180 degrees.
So 1 minus
So-
1 minus 11.
Can you explain what you're trying to do?
So
Oh no.
why use 180?
Okay. This comes from the original derivation of the reduction formula, which I I didn't want to go over to make things more complicated for you. You understand? So the reason why we don't use 270 degrees is because one revolution is 360, 180 degrees after revolution, 270 is 3/4. 90 degrees is a quarter of a revolution. Now, when it comes to the reductions, our reference angles are 180, this is a half a revolution, and what? 360 degrees. Okay? Yes?
So how can you make this model? Give order.
So we get the same answer.
You are using a calculator.
The same answer.
You are not supposed to use a calculator.
Why are you
Julia, listen. I think I told you that you need to memorize this. Okay? You just have to memorize. And you are still young, your brain is still fresh, you can memorize.
So we have so many times.
No.
Home issues.
Okay. Can you allow me to carry on, please? Allow me to carry on. Alright, so from here, this 55 degrees, okay, it's like the theta there, so it becomes tan 55 degrees. Right? Then C, okay, is cos 95 degrees. 95 degrees is in which quadrant? The second quadrant. Okay, so which angle can we subtract from 180 getting 95 degrees? 85. So this becomes cos 180 degrees minus 85 degrees. Right? And this will be, that's going to be equal to negative cos 85 degrees. Alright? So that's how you do it. Okay? That's how you do it. Which angle can you subtract from 180 to get to 95? It's 85 degrees. Okay. Then let's do F. Or we can do E. So we have got sine 250 degrees. In which quadrant is 250 degrees? The third. So we write this as 180 degrees plus which angle? Which angle can we add to 180 250? 70 degrees. Yes.
So you can only use these ones.
Yes, we can't use this one. We use these reductions, that is the core ratios, when we are dealing with angles between 0 and 90 degrees. I'm sure you can see that there's 90 minus theta.
Yeah.
So we can't use the core ratios. We use those ones.
But you can matrix.
Okay, let's carry on. Yes, you can do that as well. Okay, wait. For the previous one, if you want to use the core ratios, you could use this one here.
90.
Yes, you can use that one too.
Okay, so you can.
Yes, you can use it. But you can only use it for question C. Okay? For question what? C.
Which means it was going to be minus sine 5.
Yes, but then you have to convert the sine phi. This is the answer that you got the cos 85. Then you convert the minus sine phi to 85 degrees. We can even write this as well using sine. Okay? But at this stage, I don't want to use the core ratios. Right? Alright. Can I have your attention? So here, 250 becomes minus sine 70 degrees. Right? And the last one, 222 degrees, that's F. That's cos 222 degrees. This is the same as, now this is cos, right? Which angle can we add to 180 to get 222? 42. So we write this as 180 degrees plus 42 degrees. And this will give you minus cos 42 degrees. Okay, so that's how you do it. Okay.